IC is equal to C dVc over dt. What's the average of the current in the steady state? It has to be equal to 0. Okay, it has to be equal to 0. So it means that the average of the current that goes through a resistor, it's the same as the average of the current that goes through the inductor. Okay, so if I find the average of the current that goes through the inductor, let's call this one IL average, which is going to be exactly at the half point here, at the middle of delta IL over 2. We did this like when we talked about the average of different shapes. So this is going to be the average of IL. So average of IR, it's going to be exactly equal to that, right? So, but also average of IR, it's the same as, based on Ohm's law, it's VO over R, right? So average of IR is equal to the average of VO divided by R. Since we assume that the capacitor is large enough so that the output voltage doesn't change that much, it changes a little bit, like let's say like 2%, 5%, but for this analysis, we assume that the current that goes through the resistor is always constant. It's like VO over R, or it just like changes a little bit. It might like look like something like this. It has some ripples, but the ripples are very small, not comparable to the inductor current's ripple. So this is what we have. So if I want to draw the IR, we can basically assume that it's always constant, and this value is VO over R, right? To be realistic, it's not going to be very, like it's not going to be exactly a straight line. It has like some ripples, but those ripples are very small. Again, not comparable to the inductor current's ripple. Okay, now what if I want to draw the capacitor current? What if I want to draw the capacitor current, right? So based on the KCL, the capacitor current is equal to IL minus what? IC is equal to IL minus IR. The summation of the input currents has to be equal to the summation of the output currents based on KCL. So this is what we have. So if I want to draw the capacitor current, I basically have to subtract IR from IL, right? If I do that, this is what I end up with. This is 0. This is dt. And everything is proportional. So like everything is proportional. And since this is the average, since IR, it's going to be exactly equal to the average of IL. And if you remember, for the triangle, the average is always going to be in the half point, right? So this point, it's basically dt over 2. And this point, this time, it's going to be exactly equal to this time, right? So this, again, like this zero crossing happens at the midpoint of the 1 minus d times t. Okay, so this is how our capacitor current would look like for a buck converter in the continuous conduction mode, right? Let's do an analysis for the capacitor current here. So I'm just gonna erase this one. Erase this one as well. What does amp second balance tells us or tell us about the capacitor current? The amp second balance tells us that this area has to be equal to the summation of these two areas. Okay, so the amp second balance basically tells us that in order for the in order to be in the steady state, the average of IC has to be equal to 0. It means that the area below the curve has to be, the net area has to be equal to 0. So it means that this area has to be equal to these two areas added together. Okay. And again, because IL average is the same as IO average, and IC is equal to IL minus IO. Sorry, IO. If I call this let me call it IR. IL average is the same as IR average. This is IL minus IR, and this is basically IL average, right? So, and the average for a triangular shape, it's always going to be in the half point. So this means that this is going to be delta IL divided by 2. This is going to be also delta IL divided by 2, right? If you remember, this was the inductor current. It was like this, right? And the average of it is in the half point, right? So it's as if like you shifted this down because you subtracted IR from IL, right? So if I want to calculate this area, I know the height. The height, it's going to be delta IL divided by 2. How about the base? What is the base, right? So this area is half of dt. This distance is half of dt, and this distance is half of 1 minus d times t, right? So basically this is half of t, right? The base, it's gonna be half of the period. So if I want to calculate the area, I'm just like calculating area of 1. It's gonna be, it's half base times height, right? Half of base itself, it's t over 2. This is like the period over 2 times height, which is delta IL divided by 2. So that's going to be t delta IL divided by 8. What does this area represent though? What is like the physical meaning of the integral of the current over time?